So in this video, we're going to talk about how to write balanced chemical formulas. So to get the most out of this video, I think you need to have your periodic table in front of you. You also need to be aware of the monoatomic ions that we talked about at the end of chapter 4 and review what their charges are. This slide is just sort of a summary of the ions that were listed at the end of chapter 4, because you're going to need to remember those charges with these atoms when they're an ion to write balanced chemical formulas. So to be successful in this video, you need to remember these charges with those particular atoms. You should also maybe have the list of polyatomic ions that I gave you, the name and their chemical formula and charge, because that's information you're going to need to use to write balanced chemical formulas. And so to write a balanced chemical formula for ionic compounds, which is the only kind of formula for a chemical compound you're going to have to do this with. When writing a chemical formula for an ionic compound, you know that the metal always has to go first and the non-metal has to always go second. Remember that metals like to be positively charged, cations, and nonmetals like to be negatively charged, anions. So when writing a balanced chemical formula for an ionic compound, which has a metal and a nonmetal, it's vital that when you put the two ions together, that the charges equal 0. So they are a neutral molecule. What exactly does that mean? Let's say we wanted to write the ionic compound, the ionic formula for aluminum and oxygen. So aluminum as a cation is +3 or 3 plus. Oxygen has a charge of a -2 as an anion. So if I was to put one aluminum with one oxygen, the sum of those two charges would not equal 0. Right? It would equal +1, and we can't have that in an ionic compound formula. The charges have to be equal to 0 or neutral. And so the easy way, or the quick and dirty way to do that, is to do this little, what I call crisscross applesauce technique, where to write the chemical formula for an ionic compound, you take the numeric number of the charge on one, and it becomes the subscript on the other, and vice versa. So to write the balanced chemical compound for aluminum and oxygen, it would be Al subscript 2, oxygen subscript 3. And you can double check to make sure that the charges of this compound equal 0 by just doing a little bit of algebra. I have 2 aluminums. Each one is 3 plus. I have 3 oxygen atoms. Each are -2. And the sum of that is 0. So you can feel confident that you have written a correctly balanced neutral chemical formula. And you can do that by taking the charge on one and having it be the subscript on the other. So let's do some practice. Let's do it using some monoatomic and some polyatomic ions. And so if you want to try this on your own first, you could stop the video here and then come back, and we're going to go over these 5. But you should feel comfortable being able to put cations, positively charged species, and anions, negatively charged species, together in an ionic compound to make a neutral molecule. One other thing I should say before we go over how to do 1 through 5 is you should not assume that you'll always be given the charges in the problem. Obviously, you'll be able to use your notes for quizzes and exams, so you'll have to look at those tables I gave you, but do not assume that in the problem I will give you what these charges are. Let's go ahead and jump in and let's go over these. Let's say I wanted to write the balanced ionic compound and ionic formula for sodium, Na+1, and sulfate, SO4, 2 negative. Get my pen here. So I see that sodium has a +1 charge. Sulfate is a -2 charge. So if I do my little crisscross here, I know that I'm going to need just one SO4, and I will need 2 sodiums. And again, those charges become subscripts. If I have just one of something, I don't need to put the 1. So I don't need to put the subscript 1 for SO4, but I do need to put the subscript for sodium. So my balanced formula for number 1 is going to be Na2SO4. Number 2, we've got magnesium, which is a +2 charge, and phosphate, the polyatomic phosphate, which has a -3 charge. And so doing our little crisscross again, the charge on one becomes the subscript on the other, and vice versa. So I'm going to have 3 magnesiums and 2 phosphates. Now when I write that, particularly for the phosphate, I need to make sure that I'm clearly showing that there are 2 phosphates. And so anytime you have more than one polyatomic ion when writing a chemical formula, you need to use parentheses. So the answer for this is going to be Mg, subscript 3. No parentheses needed for Mg because that's monoatomic. But since I've got more than one of the polyatomic PO4, I need to put it in parentheses and subscript 2. So that is the balanced chemical formula, the ionic compound for magnesium and phosphate. Number 3, we have 2 polyatomic ions. We have ammonium ion and carbonate ion. So doing the crisscross, you can see that we're going to have 2 NH4s and just 1 CO3 because NH4 is a +1. If you see just a plus and there's no number there, that means +1. So doing the crisscross applesauce, we need to have 2 ammoniums, again in parentheses because it's polyatomic and there's more than one, but just 1 CO3. Now we're going to do the crisscross applesauce with aluminum and sulfur. So doing that crisscross applesauce, we're going to need 2 aluminums, again subscript 2, Al2, S subscript 3. Last but not least, we have beryllium, which is in group 2, +2 charge, and the polyatomic OH hydroxide, which is a -1 charge. And so when doing the crisscross, we're going to have 1 beryllium and 2 OHs. Again, making sure that we use parentheses because we have to have more than one we need more than one of that polyatomic, subscript 2. So you should feel comfortable being able to do a situation like this for the quiz and for the exam. There are more examples on the Chapter 5 Canvas worksheet that I would recommend that you practice with as well. So that's how to write balanced ionic compounds. In the next video, we're going to start to talk about how to name these guys. Not only how to name ionic compounds, but how to name molecular compounds and how to name acids.